Assalamualaikum to Sir Akbar. Now I would like to talk about 6.1 magnetic disc. Okay. Magnetic disc is a circular platter construct of non-magnetic material called the substrate coated with magnetizable material. Data is recorded onto the latter read from the disc using a conducting core, the head. Substrate used to be aluminium. Okay, now glass improves surface uniformity to increase reliability. Okay, second, reduction in surface defect to reduce read and write error. Okay, third, better stiffness to maintain the data, and for better shock or damage resistant to avoid surface damage. Okay. Next topic is read and write mechanism. Okay, first, record and retrieve their conductive coil called a read. Maybe single read or write head on separate one. During read or write, head is stationary, letter rotate. Okay. When write, current through coil produce magnetic field. Okay. Pass send to read, magnetic pattern record on surface below. Okay, when we read, magnetic field moving relative to coil produce current. Okay, second, coil in the same for read and write. Fourth, read contemporary, separate read head close to write head, partially shielded, magnetic resistant MRC cell. Okay. Electrical resistance depend on direction of magnetic field, high frequency operation, higher storage density, and speed. Okay, next topic, data organization and formatting. Okay, data is organized into concentric ring called track on the planter. Each track is the same width as head. Adjacent tracks are separated by gaps. This gap to prevent or minimize error due to misalignment on the head or simply interference of magnetic field. The next, data transfer to and from the disc in sector. To avoid imposing an unreasonable research requirement on the system, adjacent sectors are separate. Okay, the advantage of CAV. The advantage of CAV is the amount of data that can be stored on long outer track in the only same as what can be stored on the short inner track. Okay, next topic is physical characteristic. 1. The read may either be fixed or movable with respect to the radial direction of the platter. In a fixed head disc, there is one read write head per track. Third, in movable head disc, there is only one read write head. Okay. Removable disc can be removed or replaced with another disc. For example, flopping disc and zip cartridge disc. Okay, and non-removable disc is permanently mounted in the disc drive. The hard disk in a personal computer is non-removable. The advantage of the latter type. Okay, the advantage of the latter type is that unlimited amount of data are available with a limit no disk system. Okay, some disk drives accommodate multiply platter stack vertically a fraction of an inch apart. Next, multiply platter disk employ a movable head with one read write head per platter surface. Okay, next topic is this. Platter disk employ a movable head with one read write head per platter surface. Okay, next topic is this performance parameter. The actual details of this input or output. The actual details of the input or output operation depend on the computer system, the operating system, and the nature of input or output channel and disk control hardware. When the disk drive is operating, the disk is rotated at constant speed. Okay, to read or write, the head must be positioned at this desired track and at beginning on desired sector of the track. Track selection involves moving the head in on movable head system. Seek time is the time it takes to position the head at the track. Rotational delay is the time it takes for the beginning of the sector to reach the head. Rotational delay equals access time, which is the time it takes to get into position to read or write. Transfer time is the data transfer portion of the operation, the time required for the transfer. Okay, the formula is T equal to B over Rn. Okay, T for transfer time is T equal to B over Rn. Okay, T is transfer time equal to B or number of bytes to transfer over R. R rotation speed in revolution per second and number of bytes on track. Okay, that's all for me. Thank you.
Good morning, Sir Abdullah. Today I will talk about the subtopic chapter 6.2, which is RAID. RAID is redundant array of independent disks. It is set of physical disks viewed as single logical drive by operating system. Data distributed across physical drivers can use redundant capacity to store parenting information. Six levels in RAID in common use. It is not a hierarchy. Okay. RAID level 0. No redundancy techniques are used. Data is distributed over all disks in the array. Data is divided into strips for actual storage. Similar in operation to indirect memory data storage. Can be used to support high data transfer rate by having broad transfer size be in multiples of the strip. Can support low response time by having the broad transfer size equal a strip. Support multiple strip transfer in parallel. Next, RAID level 1, which is mirror disk. Data is stripped across disk. 2 copies of each strip on separate disks. Read from either write to both. Recovery is simple. Swap faulty disk and remirror. No downtime, and it is expensive. RAID level 2. All these are used for every access disk are synchronized together. Very small strips, often single byte and word. Error connection calculated across corresponding bits on disk. Multiple parity disk store Hamming code error correction in corresponding position. Lots of redundancy, expensive, not used. RAID level 3, similar to level 2, but the difference is only one redundant disk, no matter how large the array. Simple parity bits for each set of corresponding bits. Data on field drive can be reconstructed from surviving data and parity info. Very high transfer rates. RAID level 4. Each disk operates independently. Good for high input-output requires RAID. Large strip bits by bits parity calculated across strips on each disk. Parity stored on parity disk. RAID level 5, like RAID level 4. Parity strip across all disks. round robin allocation for parity stream, a wide range level 4 bottleneck, and a parity disk, commonly used in network servers. Red level 6, introduced in a subsequent paper by the Berkeley Research KATZ28. Two different parity configurations are carried out and stored in separate blocks on different disks, provide extremely high data availability. Red level 6 incur a substantial write penalty because each write affects two parity blocks. Performance benchmark EIS 07 saw a red level 6 controller can suffer more than 30% drop in overall write performance compared with a red level 5 implementation. Red level 5 and red level 6 read performance is comparable. Thank you.
Good morning to Sir Abdullah. So today I will explain about optical memory. Okay, in this subtopic optical memory, I have three more subtopic in this subtopic. Okay, first compact disk, second digital versatile disk, and lastly high definition optic disk. Okay, we have CD, CD-ROM, CDR, CDRW, DVD, DVD-R, DVD-RW, and Blu-ray DVD. Okay, we go to compact disk. Okay, CD-ROM more rugged and have more connection devices to ensure that data can properly transfer from disk to computer. Okay, CD and CD-ROM they are made in the same way. Okay, CD-ROM, for CD-ROM, they are organized as a sequence of blocks. First, sync block, header block, data block, and auxiliary block. First, sync field identifies the beginning of block, and header contain block address and mode. Okay, mode 1, a blank data field. Mode 0, a blank data field. Mode 1, the use of an error correcting code. Mode 2 consists of 2336 bytes of user data with no error correcting code. Okay, data block, user data. Auxiliary block, additional data in mode 1, in mode 2, in mode 1. This is 288 byte error correcting code. Okay, mute. Okay, now CD recordable, known as CDR, to accommodate application in which only one or a small number of copies of a data is needed. Okay, CD rewritable, also famous with CDRW, can repeatedly return and overreturn. Okay, now digital versatile disk, DVD, replace the video tape cassette recorder, the one that we use, the tape, the bigger tape. Okay, more important, it replace the CD-ROM in personal computer and server. And in this digital versatile disk DVD, it deliver movie with impressive quality picture. Okay, and the last one, high definition optical disc, designed to store HD video, provide a great storage video capacity, and two competing disc format, HD DVD and Blu-ray disc. These are the most famous optical. This is the most famous optical disc in this world now. Thank you.